My name is Jasmine Navarro, and this is the Diet Coke and Mentos experiment, revolving around conservation of energy. So, before I begin the experiment, it is important to understand the law of conservation of energy. Although energy changes forms, the total energy of an isolated body remains constant. It is also important to remember that energy cannot be created or destroyed. You must also understand potential energy, also known as PE, stored energy, basically meaning that it has potential to do work. In this experiment, we will be working with gravitational potential energy stored due to position. The formula to find gravitational potential energy is PE equals mgh, m standing for mass, g standing for gravity, and h standing for height. We will also be working with kinetic energy, also known as Ke, the energy of motion. The formula to find Ke is 1/2 mv squared, m standing for mass and v standing for velocity. In this experiment, we will also have to calculate the velocity to find the kinetic energy. Therefore, the formula for velocity is the square root of 2Ke over m, Ke standing for kinetic energy and m standing for mass. It is also important to understand mechanical energy, the total energy Ke plus Pe. It is important to ignore both rotational and vibrational kinetic energy. Before beginning the experiment, we must first measure the height and mass of the liquid in the bottle. The mass comes out to be 200 grams, which would then be converted to 0.2 kilograms. The height of the liquid comes out to 24 centimeters, which would then be converted to 0.24 meters. Now beginning the experiment, Kayla pulls the pin releasing the Mentos into the Diet Coke. The Diet Coke then shoots upward at a height of 180 centimeters, which comes out to be 1.8 meters when converted. Now that we have the necessary measurements and have done the experiment, we can now calculate the potential energy and kinetic energy at the 3 different points. Before the liquid exploded from the Diet Coke bottle, the height at the zero level was 0.24 meters. The mass at this point was 0.2 kilograms, and gravity is always 10 meters per second squared. This information will help us calculate the potential energy and kinetic energy at the 3 different points: the zero line, the midpoint, and the top of where the liquid reached. At the midpoint, the PE and the Ke will total out to the mechanical energy. The mechanical energy is the total energy Ke plus Pe. Therefore, the Ke and Pe at this point will be exactly half. Before we make any calculations, it is important to know the final height where the liquid reached. The final height was 1.8 meters. This information will help us calculate both the Ke and Pe at the different points. Now that we have all the information that we need, we can now calculate the Pe and the Ke at the 3 different points. First, we must subtract the final height from the initial height so that we have the correct measurement to use for the PE formula. 1.8 meters minus 0.24 meters comes out to be 1.56 meters. Now that we have the correct height, we can now calculate the PE at the top where the liquid reached. To calculate the PE, it would be mass times gravity times height. Therefore, it would be 0.2 kilograms times 10 meters per second squared times 1.56 meters. This would come out to be 3.12 joules. The next calculation that we must find is the Ke at the bottom at the zero level. In order to calculate the Ke, we will be using the formula 1/2 mv squared. Before we can use the Ke formula, we must first find the velocity. The velocity formula is the square root of 2ke over m. Therefore, it will be the square root of 2 times 3.12 joules over 0.2 kilograms, totaling out to 5.59 meters per second for the velocity. Now that we know the velocity, we can now use the KE formula. It is going to be 1/2 times 0.2 kilograms times 5.59 meters per second squared, totaling out to 3.12 joules for the kinetic energy. Now, to calculate the PE and the KE at the midpoint, you must now take mechanical energy into account. Mechanical energy is the total energy KE plus PE. Therefore, if we take a look at the KE and PE of the zero level, it totals out to 3.12 joules. Now that we understand this, we can now say that the PE and the KE at the midpoint must add up to 3.12 joules. In order to calculate the PE and the KE at the midpoint, we can simply divide 3.12 joules by 2. This would equal 1.56 joules. Therefore, the PE would be 1.56 joules and the KE would be 1.56 joules. When added together, the sum would be 3.12 joules, the total mechanical energy. And that's the end of the Diet Coke and Mentos experiment. Hope you enjoyed.